Okay then. So now let's look into the 8-membered heterocycles. So 8-membered heterocycles with nitrogen has heteroatom is called azosine. So if you are looking into the synthetic methods, most of the okay, I will take a pointer. Okay. So 8-membered ring with the nitrogen as the heteroatom is called azosine. So if we are looking into the synthetic methods, most of highly unsaturated azosine have been obtained from bi or tricyclic precursors by bond reorganization process. So let's take the first method. So here, this is a bicyclic compound. So here you have to observe only the 4-member. This is the 4-electron system. Okay, so this is a 4-electron system, and it's a 2-electron system. So more precisely, it's a, diene, and this is a dienophile. What will happen here? A 4+2 cyclo addition. So 4+2 cyclo addition means this bond pair can come over here, and this bond pair will move over here. This bond pair form a bond with this carbon. So a by 4+2 cyclo addition product is obtained. So afterwards, again, what will happen? This bond pair is coming over here. This bond pair will come over here, and this bond pair is move over here. So what will happen? There will be a formation of benzene here, benzene substituted one, and also a bicyclic compound. And you know that here there is a what is called as uh, a reactant is also a bicyclic compound. Here the product is also a bicyclic compound, but the difference is there. Here it's, you can observe that there is a double bond, but here you can observe that azo group. So then what will happen here? This also undergo reorganization. What will happen? This bond pair is coming over here. Once this bond pair is coming over here, there will be a formation of N triple bond N. So, and this bond pair is coming over here. This bond pair is coming over here. So the obtained one is a 8-membered nitrogen containing heterocycle, and the name of this compound is called azosine. So here N2 is going out as a living group. So this is about how one can synthesize azosine starting with the bicyclic compound. So when it is undergoes a 4+2 cyclic addition product, so this rearranges giving rise to a bicyclic compound. This bicyclic compound undergoes elimination of nitrogen, forming a azosine as the product. So with this, I will go to the, this is what the Diels-Alder reaction. Okay. A Diels-Alder reaction is employed in the preparation of azosine. So with this, I will go to the next slide. So here also you can observe that this kind of moieties are called 1,4. This is 1 and this one is 4. 1,4. Okay. 1,4. Dihydro 1,4 dihydrobenzene 1,4 dihydrobenzene when it is treated with. So what is the name of this compound? This is the chlorine, and this is a sulfonyl group, chlorosulfonyl isocyanate. So what will happen here? There will be a 4+2 cyclo 2+2 cyclo addition, 2 electron here, 2 electron here, so forming a 4-membered ring. So once there is a formation of bicyclic compound like this, and this was treated with thiophenol. This is the thiophenol. This is not a phenol, it's a thiophenol because sulfur is there. And this anion means bonded pair, SH bonded pair, or the lone pair attack this sulfur group, and this bond pair picks up this proton. Okay. So here the living group is thiophenyl sulfuryl chloride. Thiophenyl sulfuryl chloride is the living group, and the formed one is lactam. This kind of compounds are called lactam. Lactum. Lactam. So this lactam, when it is treated with tertiary butyl oxy, this group is called tertiary butyl, and this is oxy. Tertiary butyl oxy, tetrafluoroborate. So this tetrafluoroborate tertiary butyl oxy compound, so it will act as a source of methyl group. Methyl means more particularly a carbonium cation. So what will happen? This bond pair is coming over here. This bond pair picks up the carbonium ion, forming a ether. Okay, this is called ether. Okay, more particularly, of course, this might it's an ether is formed, and afterwards, what will happen? Okay, afterwards, what will happen? So bromination, where it will bromination, you know that NBS is a allylic bromination. So it undergoes allylic bromination. Allylic means this carbon, okay, gets brominated. Of course, this carbon also gets brominated. Then afterwards, what will happen when it is treated with tertiary butoxide? So there will be a removal of uh, dehydrohalogenation, thereby forming a two double bond. So overall, what we can say that the obtained intermediate, when it is treated with the NBS, it's a allylic brominated. When it is treated with tertiary butoxide, dehydrohalogenation forming a additional double bond, because already one double bond is there, no? So additional double bond is formed. So, and this one undergo ring opening reaction. That means this bond pair come over here, this will come over here, this will come over here, forming a 8-membered ring with nitrogen as a heteroatom. And name of this compound, this is the second position, and this one is called methoxy. 2-methoxyazocin is the name of this compound. So this is about the second method of preparation of azocin. So starting with 1,4 dihydrobenzene or uh, cyclohexa, okay, cyclohexane, dihydrocyclohexane, more particularly 1,4 dihydrobenzene or 1,4 otherwise 1,4 dihydrobenzene. Otherwise, what we can say name of this compound is uh, what you can say that cyclohexadiene. And when you are mentioning cyclohexadiene, you have to mention the number. Okay, if we are starting from here, 1, 2, 3, 4, 1,4 cyclohexadiene. Okay. If you want to name it in terms of benzene, means 1,4 dihydrobenzene. When it is treated with chlorosulfonyl isocyanate, undergoes 2+2 cyclo addition product. This obtained as addition product, when it is treated with thiophenol, a lactam is obtained. A lactam undergoes treated with tertiary butyl oxy tetrafluoroborate, giving an ether. Ether is an intermediate. This intermediate on treatment with NBS and tertiary butoxide forms an additional bond formation. This undergo ring expansion, giving rise to 2-methoxyazocin. So with this, I will go to the next slide. Okay. Oh, I have to take 1 minute. I have to go here next. Right. Now it's coming. Right. So chemical reactions. So chemical reaction, you know that it's a 8-membered ring. And suppose these two pi electrons are involved in a ring formation. So what will be? So that means 2+2 addition. So there will be a new bond formation between this carbon and this carbon, and this bond is moving over here. That is how a bicyclic compound is obtained. So the obtained bicyclic compound when it is treated with a malic anhydride, okay, more particularly N-phenyl malic anhydride, what you call succinamide, no, this is N-phenyl succinamide, N-bromosuccinamide, you are aware of it, no, this is the N-phenyl succinamide. So what will happen? This will act as a diene, and this is a dienophile. This bond pair can come over here. This bond pair can pick up this proton, and this bond pair will form a bond with this carbon. So that is how a 4+2 adduct addition product is obtained. This is about one reaction of uh, azocin more particularly. So with this, I will go to the next slide. So here, you know that a bicyclic compound. This is what is this bicyclic compound? How this is obtained? This is obtained when azocin is undergoes 2+2 addition. So a bicyclic compound is obtained. This bicyclic compound is sensitive to acid. So what will happen? You know that HBr. HBr is a better known for the cleavage of ether. OCH3 is converted into OH. Once the OH is obtained, you know that this is a enol. So that means bond pair can come over here, and this can pick up that proton. So that is how lactam is obtained. Okay, this is what it means. It means that azocin gives a bicyclic compound. This bicyclic compound is unstable or reactive with the hydrogen bromide. More particularly, ethoxy group is cleaved into a alcohol. Alcohol rearranges to lactam. Okay, this is one thing you need to aware. Similarly, you can also observe that this a bicyclic compound, when it is treated with a base, a strong base called tertiary butoxide, what will happen? The anion present over here can obstruct a proton here. And once there is an obstruction of proton here, this bond pair can come over here, and this bond pair will sit on the nitrogen. So that is how the product is obtained. This product is highly unstable. It can, what happens? This bond pair can come over here, and methoxy group can pick up a proton and can go out as a methanol and leads to the formation of a what you call phenyl cyanide. Otherwise, what we can say that benzocyanide. Okay, so this is phenyl cyanide or benzonitrile. Okay, benzonitrile is the more preferred name, benzonitrile. Okay, nitrile because it is accepted in the IUPAC nomenclature. Similarly, this intermediate, when it is treated with the proton source, what will happen? So this N is replaced by the O. That means obtained one is ester. So what it means? It means that a bicyclic compound, where you will get this bicyclic compound, the azocin itself, 2-methoxyazocin itself, it will be equilibrium with the bicyclic compound. This bicyclic compound, when it is treated with potassium tertiary butoxide, it leads to an intermediate. This intermediate is if it undergoes elimination, methoxy group elimination, it gives benzonitrile. If it is react with acid source, it gives an ester. So with this, I will go to a next slide. So next slide is about the protonation, more particularly protonation in presence of potassium metal. Okay. So when we are saying about the potassium metal, so what is the role of metal? Role of metal, it will give you the electron. So potassium means it can give one electron. So 2 potassium can give 2 electron. That 2 electron is able to form a bond with the electrophile. So that means this 1 potassium can give one electron here. So when electron is sitting over on this carbon, this bond pair can picks up a proton from the proton source. Where is the proton source? The proton says Ha. Okay, Ha means what is called as mineral acid. Okay, mineral acid is nothing but a sulfuric acid, H2SO4, HCl. Okay, PTSA. All these things are, oh, of course, you can say that mineral acid means HCl and H2SO4. Okay, so potassium means it gives you an electron. Once it is giving an electron here, this will picks up a proton. So that means saturated. This is saturated. And again, one more potassium will give one more electron. So once there is a two electrons on this carbon, that will picks up a proton from the HA. HA means mineral acid. So the obtained one is dihydro 3,4 dihydroazosin. Similarly, this potassium can give electron. Okay, can give electron to this carbon. So what will happen when an electron gives to this carbon? This can come over here and this can fix up a proton. So later on, one more potassium can give electron, and then that time it can picks up a proton, can form a CH bond here. That is how a 3,6 dihydroazosin is obtained. Similarly, uh, potassium can give electron here. So when it is giving electron here, this can fix up a proton. So one more potassium give one more electron, that can fix up a proton, and that is how 7,8 dihydromethoxyhalogen is obtained. This is about the what is called as reactions of azosin. More particularly, what and all we discussed under the azosin. So we discussed about the preparation starting with the Diels order reaction. We discussed about the reaction preparation starting with the 1,4 dihydrobenzene and chlorosulfonyl isocyanate, and we discussed about the reactions, more particularly 2 plus 2 addition of azosin giving rise to bicyclic compound. Obtained bicyclic compound can react with the phenyl succinamide giving rise to Diels order adduct, and this bicyclic compound is unstable and it can react with HBr. There will be a cleavage of ether giving rise to lactam. Similarly, this bicyclic compound is a reaction with the potassium tertiary butoxide. It leads to benzonitrile as well as the ester, depends on the if a methoxy group is going out, benzonitrile is obtained. If it is treated with uh, acid source, okay, proton source, it will give an ester. Similarly, protonation, okay, in presence of potassium metal, it undergoes protonation in presence of acid, giving rise to dihydromethoxyazosins. Okay, this is about the azosin. Now let's look into the one more compound. It's a 8-membered ring with 2 nitrogen. Then it's called diazosins. Okay, here diazo means stands for 2 nitrogen. Ocin, OCINE, ocin is stands for 8-membered suffix. Okay, diazo is the prefix, ocin is the suffix. Okay, right. So then 1,2 diazosin. This is not O L. This is a C. Okay, diazosin. Okay, it's a limited. Okay, the source of literature of 1,2 diazosin is limited. So that is the reason we are talking about only the 1,4 diazosin. So it is possible to synthesize or prepare the 1,4 diazosin starting with the cis. Okay, this epoxide is cis. This also a cis. Okay, cis benzene dioxide. Okay, cis benzene dioxide. So when this is treated with sodium azide, okay, sodium azide means Na plus N3 minus. So N3 minus is a nucleophile. It will attack this carbon. One molecule will attack this carbon. Then this along with this bonded pair, it will fix up a proton when it is treated with water. giving rise to compound like this. Similarly, one more equivalent, that means two equivalent of sodium azide can convert into a this moiety. And here azide means N3. Okay, in this the living group is N2. If N2 is living means you will get a amine compound. So this, when it will happen, when it is treated with a MsCl. What is MsCl? MsCl is called methane sulfonyl chloride. Methane sulfonyl chloride means CH3SO2Cl. CH3SO2Cl is called methane sulfonyl chloride. That is usually represented as MS chloride. So when diazo, okay, diazide, okay, this is a azide. Azo means N2. So diazide compound, when it is treated with methane sulfonyl chloride, what will happen? So you know that N2 will go out. N2, one N2 from here, another N2 from here, and this one is gets converted into NHMS. So MS, nothing but a methane sulfonyl group. CH3SO2 group is called methane sulfonyl group. So later on, what will happen? You similarly, you know that CH3SO2Cl, it can also react with nucleophiles. Okay, OH is a nucleophile, and this will be a electrophile. There will be a new bond formation between this oxygen and sulfur group. Okay, so that is how OMS is obtained. Okay, suppose TS means tosylate. This is what you call methyl sulfonate. Okay, OMS, methyl sulfonate. So then what will happen with methyl sulfonate is a living group. So this bond pair can attack here and this will go out. Similarly, bond pair or the bond pair or lone pair can attack here, this will go out. So forming a what you can say that cis benzene, uh, two nitrogens are there, isn't it? Maybe you can also observe that what is that uh, aziridine. This is one aziridine, this is another aziridine. Okay, so an intermediate formed like this. Okay, then all these things are intermediates only, and these are not isolated. And this is about talking about the most probable mechanism for the conversion of cis benzene dioxide into a 1,4 diazosine compound. Okay, so what will happen here? This bond pair is coming over here, this will go to here, this will come to here. So that means what is called as a uh, ring opening or ring expansion, giving rise to 8-membered ring. And this is a MS. MS means methane sulfonyl chloride. That means there will be a bond between nitrogen and sulfur group, SO2 group, and then methyl group. So this 2-methyl sulfonyl can be removed when it is treated with the potassium in ammonia. Okay, this is also a kind of Birch reduction. Potassium will give you the electrons, and ammonia will act as a source of proton. So this methane sulfonyl group is going out, and the obtained one is NH. NH here, NH here. So this is about how the benzene cis dioxide is converted into a 1,4 diazosine. So this is one method of preparation of 1,4 diazosine. With this, I will go to the next slide. So next slide, we are taking the reactant is the uh, cis benzene trioxide. Okay, this is cis benzene trioxide.
You.
Hello. Okay, right. So cis benzene trioxide. So this one, when it is treated with sodium azide, So it will attack here, okay, and then okay. So right, it will attack here and there and here. So a epoxide is a ring opening of the epoxide, a forming an intermediate like this. Then afterwards, what will happen? As usual, here tosyl chloride, TS chloride means a tosyl chloride is used. So this tosyl chloride N3 is in this N3, N2 will go out, and the remaining N react with this tosyl group. Okay, and similarly, what you can observe here, the hydroxy groups, 3 hydroxy group also react with the tosyl chloride converted into tosylate. OTS is called tosylate. So a intermediate form obtained like this, and then what will happen? What you need to observe here? Initially, there will be a reaction of azide with this carbon atom, and later on, azide is converted into amine. So once azide, how it will convert N3 to NH2 by elimination of N2. N2 is a nitrogen gas. Then afterwards, what will happen? There will be a new bond formation between this nitrogen and this carbon. Okay, so that is how a compound is obtained. And the obtained one is when it is treated with 2 molecule of alkyl halide. So 2 nitrogens are gets alkylated. Then afterwards, when 2 nitrogens are alkylated, when one NH is free, when this is treated with uh, nitric oxide tetrafluoroborate. Okay, this will act as a source of NO2. Okay, nitric oxide tetrafluoro. This is not fluoro, it's a tetrafluoroborate. It will act as a source of NO. So this NO is attached here, means nitroso compound. So now it is a nitroso compound is obtained. So this nitroso compound, uh, how there will be a ring opening, how it will open? This bond pair is coming over here, and this will go out. This nitrogen takes up this bonded pair electron and going out as a N2O. N2, I think you know that N2O. N2O is the laughing gas. Okay. So in this reaction, N2O is released. Okay. So then what will happen? This bond pair is coming over. This will come over here. This will come to this. So that means a 8-membered ring, more particularly alkylated, N-alkylated one is obtained. So this D-N-alkylation can be achieved by treating with the potassium in ammonia. Okay, this is a Birch reduction kind of reaction. Here the potassium supplies electron and this will go out. Okay, the obtained one is called 1,4 diazosine. So with these are the 2 methods of preparation of 1,4 diazosine. So one first method of synthesis is starting with the cis benzene dioxide, and the second method is starting with the cis benzene trioxide. Okay, so with this I will go to the next slide. Next slide is about the reactions of 1,4 diazosine. Okay, I am not discussing about the reactions. I am directly going for uh, dioxosine. Okay, dioxosine again means it's a 8-membered ring with 2 oxygen as the heteroatom. So dioxa means it's a oxygen, it's a prefix, and ocine, OCINE is the suffix for 8-membered ring. So 1,4 dioxosine is the structure of this one, and it is possible to synthesize 1,4 dioxosine starting with 4,5. This position of carbon is 4,5. 4,5 epoxy cyclohexene. So that means 1,4 dioxazine, it is possible to synthesize starting with the 4,5 epoxy cyclohexane. So this one, when it is treated with NBS, you know that NBS is the one which brominate the allylic carbon. This carbon is brominated. This carbon also brominated. And here it is possible to get two kind of products. So one may be a trans, another may be a cis. This is a cis and this is a trans. Suppose a trans one, when it is treated with sulfuric acid, so this double bond is converted into a diol. Is it this double bond? No. A ring opening, epoxide is opened in such a way that cis diol is obtained. Similarly, this obtained cis diol, you know that sulfuric acid is a dehydrating agent or dehydrohalogenating agent. You know that maybe the bond pair or lone pair can attack here and Br will go out. Bond pair or lone pair can attack here, this will go out. That means two epoxide is formed. Okay, so then this epoxide, 2 epoxide, when it is treated with bromine, okay, you know that this double bond, okay, uh, brominated more particularly. Yes, it is. This is also a you know that what is called as bromination and dehydrohalogenation. So it is possible to get a compound like this. Okay, so this also obtained from the trans compound. How? Here the, so this is the sulfuric acid, whereas this one is what is called as peracid. Peracid, you know that it's a oxidizing agent. So what it will do? It will oxidize, means give a addition of oxygen to this double bond. That means epoxide is formed. Diepoxide is formed. So it's an another method. Whereas here is a different method, but here a peracid is used and formed a compound epoxide like this. So later on, when it is treated with a base, this bond pair can come over here, and this bond, means this oxygen will form a new bond with this carbon. So that is how a compound is obtained. Okay, so this compound is also obtained from the trans. So once there is a formation of this compound, then what will happen? Ring expansion. How is the ring expansion? This bond pair is coming over here, this will go over here, and this will come over here. A 1,4, okay, 1,4 dioxazine is obtained. Of course, bromo substituted 1,4 dioxazine is obtained. So what, maybe you can say that so 1, 2, 3, 4, 5, 6, 7, 7 bromo, 1,4 dioxazine is obtained. So this bromine can be replaced with hydrogen by treating with the uh, uh, what you call tributyl tin hydride. So tributyl tin hydride is nothing but a reduction only. It will act as a source of hydride. I think you know that the conversion of bromo to the hydrogen, okay, it follows a free radical reaction. You can also try to write the mechanism for the conversion of bromo, means to the hydrocarbon. Okay, so this is how 1,4 dioxazine is obtained, starting with the 4,5 epoxy cyclohexene. Okay, so this is the one method of preparation of 1,4 dioxazine. So with this, I will go to the next slide. So next slide, I am taking about the one more compound is called dithiones. Dithiones means if suppose a heterocyclic compound contains a 2 sulfur atoms at the 1,4 position, then we can say that 1,4 dithiosine. So here How one can prepare dithiosine? It is possible to prepare this 1,4 dithiosine starting with a bicyclic compound. More particularly, what is the name of this bicyclic compound? Uh, uh, Maybe acetoxy. This is OAC, means acetoxy group. Okay, acetoxy. Okay, yeah, and 2 5. Okay, this is 1 2 3 4 5. So that means 2 comma 5 dithio. Okay, 2 comma 5 dithio bicyclic. Okay, and 4. Okay, what it means? 4 means this is 1 carbon, 2 3 4 4, and this 2 1 2 is this one. Okay, and 0, there is no other carbon here, a bridge, there is no bridged one. So that is the reason. It's a IUPAC name of this compound. Acetoxy, 1 acetoxy, dithio, bicyclo, 4 means this side, 2 means this side, 0 means there is no here, there is no carbon here. Octadiene, octadione. So where is the O? No. Okay, there is no O here. Okay. Right. So what you can observe, just you take this moiety. So what is that? 1 acetoxy, 2 comma 5 uh, dithio, bicyclo, 4 comma 2 comma O, octane. Okay, there is no di here. Okay, DIO instead of O, it is A is there. Okay, so what maybe I can take the pencil. This is not there. Okay, this I also not there, and